Okay, so hello everyone, welcome to my video. This is auto threshold remaining part for that project. Okay, let's start from where we have left off. For rule based, it means some conditions are there, like generate the alert based on some static threshold. For example, call duration greater than 1000 minutes. It can be also count of calls greater than 10, 15, 20. It will be also like value $200, $500, and you have to you are monitoring internet, then it is also volume based. It depends it totally on the condition based. So rules are like that. It is a traditional this is called traditional based fraud detection system. So examples are there. Similarly, high duration calls to known high risk destination, overlapping calls, one call has not ended, another started. So that's why simple implementation relies on domain expertise. Similarly, what is AI based fraud detection? So when I say AI based fraud detection, so it goes for both AI and ML also. Whether AI or ML, both have same features. It learns complex data, hidden data from patterns from data. So it reduces false positives. What happens, when somebody we have trained the model that some hot list destinations are there for particular countries that are blacklisted. So and what happens is the same call duration or some same call pattern, same timing, same weekend calling, and frequency of calling is same, then it will generate the high probability on those records also. So as per our use case of fraud, telecommunication fraud, I mean. It will learn complex and hidden patterns. I will explain this all in very detailed manner when we see the production part and testing part and then implementation. So yeah, so it uses probabilities and features, whatever features you have given. And so what is the importance of every feature? And so for fraud probabilities will be there, if for fraud model, and as overlap probabilities if you are generating the overlap, differentiate between overlap call and normal call. So these this that's why they're called flagged based on learned behavior anomalies. Okay, so here we are. These are the training records that I have given to the models. So you can see it's a very simple, features we I have made. Simply caller number is there, destination is there, minutes of calling, call start time and end time, and then there are fraud types. What type of different frauds that I have classified. There is threshold. What was the last threshold last time the alert fired? And this is the alert column. So it tells that last time which record was not fraud and which was fraud. Zero stands for not fraud, normal you can see, and one stands for fraud. Like different type of names are there. So there are two y's this time. This column one y, this column one y. So these two columns that model will target to predict. So let's put a filter and I will surely tell you different type of fraud. So simply I have put some records and put the last thresholds and name it. Like you can see destination fraud. When we are talking about destination fraud, it is for particular destination like Angola, Bulgaria, Cuba, Albania. So what happened was last time caller numbers made some excessive callings. You can see here. What is the pattern? You can see here the calling patterns suggesting that every call is at least more than 1000 minutes. So simply the model should learn if this type of records will come, and then firstly it has to predict that it is a fraudulent and how much, and then what is the fraud type. For this particular, the model has to tell also that it is destination fraud. Similarly, you will go to high risk destination, and you can see here the calling pattern is saying that for high risk destination there are multiple calls to single destination like Latvia here. At least five calls are there, three calls for Guinea Bissau, and all are we can see that at least 200 minutes calling are there. So we have to train the model in such a way that it will catch those records, and then also give the name of high risk destination. Similarly, third type is overlap call fraud. You can see multiple calls are there, but you can see that similar number when calling, and 5 2 call start time, call end time 5:31, in between 5:28 call started. So for the same caller number, if same caller number call has not ended first call and next call started in between, then only we can tell na, we can say na that it's a overlap call fraud. So last time threshold was 90% and alert was one. These are fraud records mean one means fraud record. So model has to learn that when this happens, then it is overlap call fraud. Firstly, it is fraudulent record, and then the fraud type model will say that it is a overlap call fraud. So alert will fire. Okay, let's go to hack attempt. I tell you now, only four types I have given for very. That's why I have made very few columns, and few fraud types to show to audience, that the audience will understand easily. So PBX hack attempt, you can say here, see here. I mean caller numbers: Latvia, Cuba, Aruba. Okay, so what happening is you can see here short calls are there. I told you in last video of PBX, when I made AI based PBX rules, that firstly the fraudsters use techniques to check whether the calls are passing or not. So they make short calls to check that PBX has been hacked, and then start abusing the services. So like that only, again the model will have to learn the pattern, and next time any destination pattern, similar pattern is there, then the alert model will identify it as a fraudulent record, and fraud type model will have to tell that it is PBX back hack attempt. And what I have done, I have also put to learn versus the normal versus fraud records. So these are normal records. These all are normal record. You have to give it, because model has to find a relationship between the fraud versus not fraud records. This requires domain expertise. When you are a fraud detection expert, then all this is needed. So, and you have to carefully train the model for all four fraud types, that it will not mix. I have fine tuned the model in such a way, and I will also show the results. But what happened, what is the benefits? I will tell you when we will go to the production part. Okay, so before going to Python code and running, firing the alerts, I mean, from the model, we will just have a quick overview of ANN based fraud detection and why ANN differs from others. So simply, as we all know, what is an artificial neural network is a model inspired by human brain, and it consists of layers of interconnected nodes, neurons. So here you can see biological neuron, which have these dendrites. So whenever we touch something hot or cold, these dendrites send information to brain, and brain is trained in such a way that it will take action whatever it does. So similarly, and we in deep learning we call these neurons as perceptron. So now you know that when we define an model, it is called MLP, multi-layer perceptron. So in fraud detection, why it is beneficial? Because it learns complex patterns from data through multiple layers. That's why it is suitable for fraud detection tasks. Okay, let's go to next slide, and it will tell you more about it. Let me drag it below. Okay, so here we are, x1, x2, x3. This is input layer, means this is our neurons. So these features I have already written over here in context to our telecommunication fraud: call duration, minutes, overlap. So these are the features. It can be many more, but for representation purpose, only three I have mentioned. So these are passed to these neurons as input features. Okay, then there are corresponding weights. For x1, W1 weight is there. Similarly, W2 and W3. So what are these weights? These are parameters that define the importance of each input feature. For example, if we want to give overlap feature more importance, then for w1 it is 1, w2 it is 1, again 1, then w3 we will give the importance as 2, then the importance become twice the importance of minutes and call duration. Okay, all right. Then why we all know that it is our predicted output. This is the result after processing the input. Means call records. Okay. So similarly, we have this one, green one, integration plus activation function. So yeah. So what it does, you can see here, it integrates the wi into xi, means every weight and corresponding neuron will be multiplied, and we will then do the summation. Summation will be sum of the value. Okay. So you can see here also one extra neuron is here, denoted by B. You can here see this is bias neuron. For this neuron, x naught is equal to 1. It is the value is usually 1. So 1 into B becomes B. So why this bias neuron has been taken? Because we will adjust the output of neurons through this. The activation function, treat it like an additional degree of freedom. So the bias, this is a bias neuron, will allows the activation function to shift the output to better fit the data. So you can I told you that take an additional degree of freedom, so that model will better fit. So when you have an extra neuron, so yeah, you can use it uh, to better right fit the model. So that's it from here. So that's why the equation was like this one: y is equal to wx plus b, and if we have multiple neurons, then it becomes y is equal to w1x1 plus w2x2 plus w3x3 plus v. And and yeah, and when integration function combines the input, as I was telling you, combines the inputs of x and weights w and bias b, then what happens, it come up with, and when it sums up the values, so it comes up with the pre-activation value. And this pre-activation value is passed to activation function, then it passes the value to the to introduce the non-linearity in the model. So this part is crucial. Understand the non-linearity in, just I will tell you in a very simple way. uh, okay. Okay, so as I was telling about non-linearity, so without non-linearity, the model will simply build a linear relationship, and regardless of its depth. So take a simple example, means model will do this, like linear equation. What happens? We all know equation of a straight line is y is equal to m into x plus c. I have showed this in previous project also in detail, but simply y is our predicted value. What is m? M is slope, I mean rate of change in y due to x, and c is the interception value, where y is intercepted, and where x is equal to 0. So take the simple example: some student is studying, x is our over studied and y is our exam score, and we are predicting y. Okay, so x is our input feature, overstudied. See this: if the relationship is linear, what happens? Y is equal to, I'm taking in m as 2 and c as 5. This is just for representation purpose. So y is equal to 2x plus 5. So x is hours. The student is, how many hours per week the student is studying. So it will affect y. How much how y is affected. So overstudied, we put like 10 hours per week. 10 into 2 20 plus 5 25. Then the exam score become 25. Similarly 20, when x is 20, 20 into 40, 40 plus 5 45. Exam score becomes 45. Similarly for 30 hours per week, 30 into 2 60, 60 plus 5 65. So you can see here, It's easy to understand equation of a straight line and where x and y are directly proportional. Simply x is affecting y and the relationship is very understandable, and this is a linear relationship. So model will be, without non-linearity, model will build this relationship. But in fraud, we need to dig deeper, because there are a number of features which will affect the fraud pattern, and we don't know why they are affecting. So the model has to learn. I mean, the main thing is that model will be effective. The main aim is like that. So next slide. Let me go to next slide. Okay, so here are we in a nonlinear equation. So that's why I was telling that artificial neural network has to learn the nonlinearity because of this. Now understand nonlinear equation. So what happened? Nonlinear equation is it's parabolic curve. The relationship is quadratic. Means you can see like waves are like that, na, up and down. So the changes are unpredictable. So the equation is like that: y is equal to x square plus 2x plus 5. This is quadratic equation, and I have taken the same m and c as same 2 and 5 for representation purpose. Now see what happens. At that time, now we will put same use case. X is our overstudied by a student, and y is our, we are predicting y, that is our exam score. Now when we put 1 hour, the student overstudied 1 hour per week, per week, the exam score becomes how much? 1. The square of 1 is 1, plus 2 into 1 twice of 1 is 2, plus 5. So 5 plus 2 7 plus 1 8. And when 5 hours per week, so see now, 5 square, 5 into 5 25, plus 5 into 2 10, and plus 5, so 25 plus 5 30, 30 plus 10 40. So see, 5 hours per week. The exam score is 40, at least passing mark is 40, then the student is passed just studying 5 hours per week. So do you understand now what these stats are saying on its own? Then similarly on 7 hours per week, so 7 into 7 49, plus 7 to the 14 plus 5, so it becomes 68. So if the exam score becomes 68, just studying 7 hours per week. So as I was stating, small changes in x can lead to unpredictable changes in y. That's why AN goes for non-linearity, because we don't know in fraud detection or in any other complex relationship which factors are affecting. So similarly, if I okay, so as I was stating, yeah. So you can see here small changes can lead to unpredictable changes, and y is not proportional to x. Similarly, when here only you can see that some in linear equation, when somebody was studying 10 hours per week, the score was 25 only, 20 hours 45, 30 hours 65. But here only these values have given so much high score. So you must be thinking, what is the difference? How they are performing well? So that's why the nonlinearity, and we need means we need nonlinear activation functions like we use in artificial neural network, like sigmoid function is there, and then tanh function is there, ReLU function is there. They all enable the network to capture complex pattern in data, which is required for our fraud detection. That is very much needed. So that's why I believe that was a very simple yeah, way to telling about this. And now we will go to the production. Okay, so before going to coding screen, there is an update. I will be demonstrated only the third and final and best version. So that is AI plus ML based fraud detection model. It will target the fraud type only. And what it does is that it learns complex and hidden patterns from data. Not only that, but it adapts to new emerging fraud trend as well. And it reduce false positives by understanding hidden patterns. Fraud probability will be used, but the thing is that I have designed in such a way that it will use extreme feature engineering, which plus blended ensemble learning. I will explain all this. So examples are: calls are flagged as fraud based on learned behavior anomalies, identify new high risk registration automatically, and fraud type detection based on deep data analytics. Okay. Okay, so let's quickly understand, have a quick overview of what it does. So this is, as I told you before, this is an advanced AI fraud detection system, and high level AI ML setup. So what it does, it is this advanced AI and ML driven fraud detection system. It is fully automated. It has intelligent fraud detection system that uses stacking model. So what I have done is I have gone ahead and I have make a high performance dual ensemble fraud detection system. Just I will explain this, combining AI and machine learning both. Then fraud types, different fraud types. It will classify different fraud types. So just a little view: data input, double stack model will be used, fraud type prediction will be predicted. Okay, so we'll go to the next slide now. Yeah, stacking model for fraud type classification. So this is it. I will explain now. You will understand that these are four types that model has to predict correctly: overlap call fraud, destination fraud, high risk destination, and PBX hack attempt. So what will happen? As you know, stacked model uses the predictions of base model, and final model learns the prediction and make final prediction. So in this, what is update is we have used four machine learning models: random forest plus gradient boosting plus extra tree plus cat boost. So all these models will be trained, and they will predict, their predictions will be given to meta model, that is our logistic regression model. Okay, similarly, three MLP model, means AI models, will be used: one, two, three, four. So they will make predictions, they will be trained and will predictions, and the predictions will be given to meta model, that is again our logistic regression model. So then in this way, the prediction will be given to stack model 1 and stack model 2 be. So you can imagine it like prediction 1 plus prediction 2. So prediction 1 from this final model, and prediction 2 from this combined AI model will be given to again a meta model, that is logistic regression, and it will make a final prediction. So you can understand now, this is a blended ensemble. When we combine multiple models, this is called ensemble machine learning. Ensemble, yeah, ensemble method, but now it is blended ensemble method, because in one set we have all the four machine learning model, top machine learning model for this use case of telecom fraud. And in another set we have four AI models, with high configuration for learning the non-linearity, as I explained before, for fraud detection. So combined predictions will be used by both meta final models, and then their predictions separately will be given to again to the meta model, that is again a logistic regression model, that will make the final prediction. Okay, let's go to coding screen. Okay, so here we are in our coding screen, and this is our final model, best model, auto threshold for time model, self learning model 1.2, blended ensemble model. And already I have explained which we are using ML models and AI models on different sets with meta models for making predictions, uh, using their predictions, and then again using prediction 1 plus 2 plus meta model to make the final prediction. So here we have, I will quickly overview that we have different extreme feature engineering I was telling about. So you have to do this because model has relation, find relation between x and y. So both ML models, set 1 and AI model set 2, will build relationship between our x's and y's. But with help of these feature engineerings, it will be easy for them, and they can understand the data. So you can see how many features are there. I have, formulas to calculate different type of, uh, calling pattern. No, I mean, calling calculations. Average call duration per caller per destination, count per caller per destination. So like this only, and these you can see here. Even the describing the fraud types, we have put greater than zero, so that there should not be any threshold for call durations. Just some mandatory condition for every fraud type is there, like call count per destination equal to 1, unique caller per destination equal to 1 for destination fraud. Similarly, count call per caller greater than equal to 1, or unique caller per destination greater than 2 for high risk destination. And similarly for hack attempt, and and even we have given formula for to catch the overlap call. Okay, so it must be here somewhere. Okay, so I believe here is the overlap. So yeah, so the thing was, you have to give the calculation so that model will understand. Okay, then again here we have defined our for machine learning model, top machine learning model for our this use case of telecom fraud, that are very good in finding patterns, historical patterns, and finding new trends. And then AI models, which goes for non-linearity, and then final model, logistic regression. So yeah, already I have described what will happen, so let's not waste the time. I will just tell you that we will use three files, different data files, so that we will check model has to correctly fire for the and predict the correctly fire the fraudulent record, and correctly predict the fraud type. Okay, so yeah, means I will hit this play button and run the code. So okay, so the code has started running live, and it is trained on live scenario. I mean, in front of you, and then will make prediction in front of you. I have designed the code in such a way. You can see here started, you know loading the data. Okay, wait a second. Okay, here, see, training the model after loading and splitting the data, because it will take time. It has two different set of model to train. One set is ML model, one set is AI model, and corresponding meta model will make predictions, as I told you before. Just wait, and we will have results. Okay, wow, classification report. And then yeah, so initial predictions are these, and final prediction are these. We have taken the threshold of 0.68, I mean it 68%. So it has shown, I have put the initial prediction. It will show all the records which are the data set is having, but it will write not qualified, which is not qualified, and for those who are qualified are these one. And for those alert sent successfully, if we go to email window now. Oh wow, yeah. So this is P1 priority 1 AI plus ML based fraud alert, and now we'll compare. Firstly, I will just open that data file that I have copied here, and we will see. So Cuba and Somalia are both high duration, destination. So destination fraud are there. Let me open it. Okay. So for Cuba, you can see here 1123 minutes. If I go back, Cuba 1123 minutes, I will just highlight it as green, so that we will know that correctly identified. Then we will go step by step. Somalia, another high duration, 3,977 minutes. And if I go here, and if you can see here, another is same 3,977 minutes, correctly identified. And then again, if we go back and see, we will check for this one now. When calls, two calls for same number ending with 24376, it should be overlap call. Why? 351 call started, 451 call ended. In 415 in between the call started for same number. So let's go back and if we go overlap call fraud, see same number ending with 24376. I open 60-minute, 30-minute call, 60-minute, 30-minute call. So correctly identified. So system should be like that only, correctly identified, and false positive should be negligible. And then we will check for we'll now check for this high risk destination. Three calls to Guinea-Bissau, same destination by distinct number. Distinct number means different numbers. 89658 ending with. Similarly, 87478 87478 ending with, 51260 ending with. So it should be grouped for the Harris destination means combined. So see, it fired for instead of caller number fired alert fired for country name Guinea-Bissau and Harris under Harris destination fraud. So you can see here this is AI plus ML based fraud alert for high risk destination with higher probability of fraud. Here are details. Three calls are grouped for same destination. Fraud type is high risk destination. AI plus ML based system disposition for this alert is fraud. Outgoing service for these numbers are temporarily barred. So this should be the management decision, which on which extreme high scenario they want to put the barring, and even then on duty analyst or automated call will contact the customer. So similarly, last is left with these ones, short calls, number ending with 501. You can see here, and one 502. PBX hack attempt. See, 501 Latvia, 5 minute, 7 minute, 10 minute. So again, AI plus ML based fraud alert, fraud type detected, previous hack attempt. MI AI plus ML based system disposition for this alert, fraud outgoing services are temporarily barred. So here I will again, firstly Guinea-Bissau calls are being identified. So we have to mark all which we have checked. Okay, so now even these one, and so that we can we will easily analyze. So yeah, and similarly 502 three calls, so I have highlighted green. So it means that these should have not fired. These are not fraud records, not qualified records, because model are not trained on these records, because these are normal patterns according to our training records. Namibia, France, Bangladesh, India, Australia. Okay, let me go, because I told you for initial record I have placed that make a comment not qualified for any fraud type. Namibia, see, 35%. Then this 20 minutes call for France not qualified for any fraud type, 37%. And then similarly, Bangladesh, we can see here Bangladesh, and Bangladesh not qualified for any fraud type, 38% only. And again India 1 minute call and Australia 1 minute call. Then again India not 1 minute call not qualified for any fraud type, 1 minute call not qualified for any type. Both got 37% each. So wow, what a beauty! See what happened with our stacked models, combined ML models one side, AI model one side, and then prediction going on. So what happens is what happens is your predictions got refined. So see, for not fraud cases, they have fallen, the probability is so much low. See, for every record, not qualified 35%, not qualified 37%, not qualified 38%, below 40%, not qualified any fraud type 37%, again 37%, fraud types 81%, 76, 85, 83. Similarly, all 81, 81, like this, and 76 for high risk session, 76, 76. So our average calculated threshold becomes 0.68. We are using, again, if I show you, we are using the data science ideology of average, or and mean, I mean, for stands for average plus standard deviation. That is, you see, mean plus standard deviation, else average. So I have made some condition to adjust with the average and standard deviation. So this is something fraud expertise, you come to know when you know your model behavior, and you have to adjust it as per data set, because data set will have a different variation also. So your calculation of this threshold should be very precise, so that it only it only adjusts when you adjust your model to make probabilities like neat and clean probabilities, to segregate between fraud and not fraud very easily. That's why our results were bang on target. We have we have we have fallen the probabilities for not fraud class very low, and then for a fraud class high. Okay, so this should be the approach to make your model a right fit model. Okay, and we will now see another second data file that uh, that is new only, and I will show you which records it contains, and which records uh, should fall under the fraud category. Okay, so this one. Okay, so let me copy this. Okay, so see, I have taken, firstly I will close that because we have to you know ran that also. I will import that in the code also. So you can see here I have so many call duration or different call duration with different destinations to bluff with the model, but only these Somalia 3977 1123 minute calls to Myanmar. I changed the names also. So again these calls for overlap, and this only. See, only four records, and this one is same caller number. So these two records should be identified under one alert caller overlap call, and two destination fraud for different caller number. So see, in all these how much are these? 31 call records, only four record system has to identify. Okay, so let's again hit the code. Okay, I believe you guys are ready. I'm also ready, and we will just see the results. Let me clean this email window by deleting the old alerts, and let's go for it. Okay, okay, started. Okay, okay, very good. Loading and splitting the data and training the model have started. See, training the model. It will take only time when training the model, because there are n number of models, and then there will no time in which in a split second it will make predictions once it is ready, because data is very small. And that's why I have not used so much of parameter tuning methods like randomized search CV you can use, grid search CV you can use, but there is no requirement. This is again I'm telling blended ensemble method, AI plus ML. Oh wow, okay, we have results. Initial predictions. So initial predictions, these much. See, what a beauty. Destination fraud 3977 minutes, that is recognized. 1123 minutes, that is recognized, and that only calls to Benin overlap call, that is recognized. All other are not qualified. And for final prediction, only for those records who have qualified are there. I told you four records. Two records are for same color number. Three alert will be formed, and three alert sent successfully. Okay, here are the results. Destination fraud, overlap call fraud. Let's open this. Okay. Oh my god. Oh my god. See, ban in 60 minutes calls time, and overlap fraud. AI plus ML based fraud. Temporarily barred. This is totally management decision. And then Somalia. Destination fraud. 3977 minutes. This makes on duty analyst work so easy. He has to, feedback loop has to be made. It will check with the companies where hack attempt happens, or this check with the customer where calling happens. See, 1123 minutes. Myanmar name was not in destination. I mean training data. Still, it has been identified. So, like, let's analyze. See, again, what a beauty. See, model has, how has classified. Firstly, you can see the method used as per our data science, methodologies. Calculated threshold is 0.5959% using mean plus std. This time variation was there, so the model has adjusted. So what it has done, it had average, and it added a standard deviation because there was a deviation. So that has to be added as per our, auto threshold, function. So then that's why you can see here, then above the threshold. See, for fraud, what is the threshold? 84%. Another 81%. For overlap call fraud, 81%. And for all others, 38, 45, 38, 37, similarly 33, 31, 48, 35. See how this, blended ensemble model is performing. It is throwing the upper class of fraud probability to one side, throwing the not fraud class of probabilities to the lower side. So this should be the model. This is the right fitted model. I told you that, when combine AI plus ML, and your use case, and you which models are best for your use case, like this for use case of our telecom fraud. So you can, affect the prediction. So predictions are in our favor. Okay. So I think let's go to the, last part now. And what we will do, we will this is tricky. This third part is tricky because this third file, CDR new to consist of some thing that model is not being trained upon. I will show you. Let me just copy the data. Copy. I will paste here again, so that you can have, we will discuss which records should fall, and then I will close this because we have to import this data in our code also. Sorry. Okay. Okay. So here we are. So here we are. I'm in on the coding screen, and I have changed the new data to that only file called CDR new. But before this, I will just show you this part. I have already played for our stacked versions. I mean, ML models one side, and AI model this one side. I have shown this statistics of this SHAP analytics. SHAP analytics, what it does, it will show which features are, model is using, and how much importance it is giving to that. Okay. So if we see, you can see here, generating this is SHAP summary for stacked model 1. You can see sorry, for every, like call duration here, call duration, and then average call duration per destination here, call count per caller, and average call duration per caller. So these four features are, uh, are using by the model with the importances. Right, if the data points are towards right, it means plus point, and these are minus point. But you can see here, towards the right, and if they are red, it means that that feature is getting more importance to make the predictions. Like call count per caller has many red dots, and from minus 0.25 to till 0, and it is towards the positive side of 0.25 maximum. So right side is positive side. So you can see here, call count per caller is, affecting the predictions for stacked model 1 for ML models. And then also some, here are some points: average call duration per caller with the red means high importance. Similarly, some average call duration have blue points majorly towards the positive, and then this call duration it has, but towards the borderline also, towards the positive point also. So let's check for the stacked model 2. That is our set of AI models, and meta model for both logistic regression. So see, call count per caller here. You can see here again AI models, and our meta model. These are very very highly. Well, this is getting the highest importance. This feature, call count per caller, in making the prediction. Then we have average call duration per destination also. Some here, and average call duration with also, and less is call duration towards the border, and few little bit above that. So yeah, so it will give you idea how your model behaves, and you can understand what factors are affecting the predictions. So where we are, so we will just you know hit the code and run the code, I mean, and we will see the results. I will just check email window screen. Yeah. So what I was telling you, that in this file, what is the bluff, that this France call has to be recognized, because this call is less than 1000 minutes, and more than 1000 are being trained, the model is being trained. So this is something emerging, fraud, that they have changed the destination now. France, clean destination they are calling, and with some less duration. They know that our mobile numbers we have used are getting barred, I mean caller numbers. Then they will target that, yeah, means less duration, makes some less duration call. They might be the our calls, they have monitoring the threshold. So they all know, fraudster all knows about the how these fraud system works. So they keep changing their destination frequently, keep changing their calling patterns frequently. Sometimes they go to roaming to abuse the services, because the data gets late. They know everything, that if we go to roaming and use the numbers over there, then the data to the home circle will come late. So we'll have privilege to abuse the services. Okay, so this will should be caught by the AI plus ML model. Let's go and hit the code. Okay, just before hitting the run button, I was just yeah, change to new to. That's all I want to check, and I want to check the email. Screen should be clear. Okay, very good. I mean, very nice. So now we will hit this run button, and soon it will give results. Let me. So loading and preparing data. Oh, wow, and you can see here. Then splitting data into training and test set, and training the model. This is main part. It will take time. In the meanwhile, I want to tell you that this fraud detection process goes like this only. You have to continuous monitoring and regular fine tuning is needed for the model, because fraud trends keep changing, and similar threshold and similar features, it will affect the model performance. So keep updating that as per pattern. And you can always, I told you, you have to make your model a right fit model, low bias, low variance, and and less noise in training data will help you. So predicting on new data. Wow, very nice, very nice. Wow. Okay. So initial prediction, it has for less than threshold, not qualified. Bangladesh and Italy not qualified. This France, see, wow, really, but your destination fraud has been classified. So alerts, final prediction for these records, alerts has been fired. So in that, France is there. You can see here 900 minutes calling, destination fraud, 76%. And you know what is our threshold, auto threshold? Using average, it is 0.75. So it has got above it 76%, and all other also 76 and more than that. So see, even though see, Cuba was there in training record, and these 1000 minutes are also there in training record, so it got 81%. But even France is not there. and 900 minutes is less than 1000 minutes. Then again, the system AI plus ML has classified it as destination fraud with 76%. So you can see here the emerging patterns have been caught, hidden patterns have been identified. We will see the alert window as well. So see, now there will be three destination fraud: Cuba, 1123 minutes, and then we have France emerging new fraud pattern, and then we have Australian call. Oh, sorry, yeah, again for Australia, I want to tell you that see this call I changed the name as Australia. So see again Australia has been recognized by models both. So this is the combined power of AI/ML. See, if you know how which models are good for your use cases, and you know how you want to fine tune your model. As I told you, using feature engineering, using giving weights, giving different weights to different fraud types. You know which in which predicting which class of fraud your model is very poor, so you have to give update the weights accordingly, so you can affect the prediction. See what a beauty. Australia call 3977 minutes, 85%, more than the in training for training record of Cuba was there in training destination was there in fraud record, and this the call duration was also above, it was in so 81%. But new name, new destination on Australia, and the AI plus ML model understand that this call, why somebody is calling 39,977 minutes means 3 day calling, continuous 3 day calling. Why somebody is calling this, so that it gave more than percentage of 81%, 85%. Similarly, France was caught. So what a beauty! So 10 on 10. So I told you I this is the best model, and I showed you all others. Guinea-Bissau hack attempt same 502 501, but I'm overlap call Benin, but I bluffed with the model with this France and Australian call, so the system has detected with very high probability. So system action has been taken. So that's why this is the best model, and this is blended ensemble model. You can see how much models: 4 ML models plus meta model, prediction number one; 4 AI model plus meta model, prediction number two; then prediction one and prediction two will be given again to meta model, then the final prediction will make. So that's why you can see here uh, that classes, major fraud classes are given high probabilities, and not fraud classes given low probabilities. See Italy, 200 minutes. If Italy have more calls, then it can fall for the category of high risk destination. But I will tell you because I have given this code manually, not qualified. The less than threshold, please put not qualified. If I remove this code, you can see the what system model has predicted on its own. Let me block that part. If I okay, let me block it from here, and let me block it till there. Okay, and yeah, till there. And also I don't have to give this. Let system generated, I am model generated for type you should give. So okay, this should on the output screen this should show now what was the initial model has given this. Okay, that's it. The run the code, I mean, in a few time it will be given. I'm just waiting, like, you don't angry on me. This is the last part, training the model. This all is time consuming, because if we have already trained and saved the model, then simply prediction will prediction the model has to be prediction on the new data set. But I want to show you that I'm not bluffing with you too. So that's why I have every time the model will be trained, and then it will make prediction in the end. So that's why. And because data was less, so it doesn't go for a long time, and it's it's good. for audience to understand all these things. And it helps me also uh, to again learn everything from start. Just in any time, it will be print only here. I have blocked the email code so function, so I'm in that part of code. So only output in the output screen it will show that Italy call got which fraud type. I mean, was the model able to predict uh, the relevance of that call to the related fraud type. We will just see in any time evaluating the model. Very nice. Saving the model and scalar, predicting on new data. You can see if everything goes right, we will have the prediction. So see, yeah, wow, what a beauty. See, this number Italy call high risk destination and with 46%. See, if there will more calls to Italy like Guinea-Bissau, see, because you can see the call volume is same 200 minutes something, 283 something. One more call, it will add some percentage of probability. One more call, then it will make some or more probability. Then initially it would have reached till 75%, and it have reached till 75%, then the alert would have been fired, because we have because that is our initial threshold for this. So this model is working perfectly as per every fraud type, new emerging fraud type. And if the frauds are gonna change the threshold, change the destination, even though it will caught. And this is very basic simple representation, because in real telecom scenario there are n number of features, there are n number of I mean these column attributes to analyze. So uh, this was a very very hectic project, but I was some way somehow I was able to pull it. And I will just recall the highlights for this model. See, this model is uniquely identifying every fraud type, so that we have trained. So it is dynamic model generated threshold for fraud detection, eliminates manual threshold setting, and reduces bias. Advanced dual ensemble detection is there. So it is the stacked model 1 and stacked model 2 are working on it. As I told you, there is a multi-layer stacked model 1 and multi-layer stacked model 2, and it is scalable. And what is real world application? Scalable across telecom systems, adapts to emerging fraud trends, supports multiple fraud types that I told you, helps taking system action for extreme scenarios. That is up to management what they want to do with the extreme scenarios. Okay. So capable of handling large data set with augmented feature for better features, for better fraud detection. Okay, and helping the on-duty analyst to just make a feedback loop with the clients and customers, so that an effective fraud detection system monitoring process can be established. So this is Akhil Singh Rawat, everyone, signing off now. Please take care and have fun. Bye bye.